Hi guys, today as a continuation of the neural coordination, we shall talk about an important chapter or important area wherein you definitely get a question in the Neet, I am sure, and I am sure you are definitely going to get a question in this area, that is the transmission of impulses. In the neuron, the impulse is produced in the cyton by dendrites, and then it is passed on to the next neuron through the axon filament. So from one end of the axon to the other end of the axon, how the impulse is transmitted, that we are going to see now. So now we are going to see the transmission of impulse inside the axon filament to pass on to the next neuron. So now we are going to see, we are restricted to ourselves that the transmission of impulses inside the axon. Now, regarding this topic, you should remember three terms. 1. Polarization. 2. Depolarization. And 3. Repolarization. So these terms you must keep in mind. Let us take up the first stage. This is the axon. Inside the axon and outside the axon. When the axon or when the neuron is at rest, where there is no impulse, let us see the condition. First stage, at rest, what happens? This membrane, the axon membrane, is in a polarized stage. What do you mean by that? So this is the transmission of impulses is done by the sodium and potassium pump channels. There are so many ionic channels. Here sodium and potassium channels are involved. So at the rest stage, when there is no impulse, what happens here? This is the axon membrane inside and this is the outside the membrane. So at rest what happens? Sodium is more outside and potassium is less inside, and there will be more positive charges outside and more negative charges inside the axon. This is the condition. So the membrane is at a polarized stage. Three sodium ions go out and 2 potassium ions come in. That is the condition. So for every 3 sodium ions, 2 potassium ions are coming in. 3 sodium ions going out, 2 potassium ions coming in. So now there is a difference of potential in the membrane, surrounding the membrane. That difference between the electrical potential across the membrane is called as the resting potential. So you can see the membrane outside more positive, inside more negative. So it's in a polarized stage. So for every 3 sodium ions going out, 2 potassium ions coming in. At this stage, there is a difference between the electrical potential across the membrane. That is called as the resting potential. That is minus 70 millivolt. So at this stage, the sodium channels are closed. Sodium ions cannot come in. So now the membrane, the axon, is at a polarized stage. More potassium outside, more positive charge outside, more negative charge inside. So the difference between the electrical potential across the membrane is called as the resting membrane potential or resting potential of the membrane, that is minus 70 millivolt. You must remember this. So at this stage, when at rest there is no stimulus, sodium ions channel is closed. Potassium channels are open and potassium ions will be going out. Sodium ions cannot come inside at rest. So now the membrane or the axon membrane is at a polarized stage. Next stage, when there is a stimulus is created in the cyton, what happens now? The sodium, you can see the sodium channels open and potassium channels are closed, and more sodium ions come inside the axon membrane. So more sodium ions move freely inside. So at this stage what happens? Since more sodium ions are coming inside, you can see the diagram here. Inside there will be more of positive charges, outside there will be less negative charges. So inside from minus 70 millivolt, the charge, the potential comes to plus 50 millivolt. You got the point? So at rest what happens? Sodium channels are closed, sodium ions cannot come in. So it is at a polarized stage. Outside the membrane more positive, inside the membrane more negative. So it is polarized stage. Now when the stimulus occurs, what happens? The sodium channels open and more sodium ions flow inside the axon. That will create another potential, that is plus 50 millivolt. So from minus 70 millivolt, the resting potential becomes plus 50 millivolt, having more positive charge inside. That is the action potential. Now the action potential is created, and that is the nerve impulse. So nerve impulse has started to move from A to B. So now this, what I said happens here. It was at a polarized stage. When stimulus takes place, the resting potential becomes action potential. From minus 70 millivolt it becomes plus 50 millivolt, and action potential is produced at the point A, and then it moves on to the point B. After reaching the point B, what happens? It becomes repolarized. It becomes repolarized. And then another action potential is created at B, and it goes on to C, and from C to D, and it goes on. I told you that movement is called as the saltatory conduction between the nodes of Raniver in the axon. So now after reaching the point B, the depolarization becomes, the depolarized stage becomes repolarized. What do you mean by that repolarization? Now what happens? You can see the sodium channels are closed, potassium channels open, and more potassium ions go out. So by which it once again regains the resting potential. Outside the membrane more positive, inside the membrane more negative, because more potassium ions go out. Sodium channels are closed. So now it regains the resting potential. So more potassium goes out, restores the resting potential. You can once again see outside the membrane more positive charge, inside the membrane negative charges. So it is called repolarization, and then this sequence repeats along the length of the axon. If this is the axon, this is repeated A to B, B to C, and C to D, and goes to the axon terminal. So likewise, this goes on. This movement, the sequence repeats along the length of the axon. This can be explained by graphical structure. You take the time on the x-axis and the membrane potential, the y-axis. You can see the resting potential here, minus 70 millivolt. Now, what happens at this stage? Sodium channels open. More sodium ions come inside the membrane, rapid sodium input, so the potential reaches to the maximum plus 50 millivolt, that is the action potential. At this stage, action potential, the stimulus is created. Now what happens? Sodium channels closed, potassium channels open, and then this depolarized condition becomes repolarized, and the plus 50 millivolt has come down to minus 70.